isn't really whoops, I shouldn't have clicked on that. Let's get the screen back there. Sorry about that. If there's not really a clear indication of where the risk is best managed, then it's typically put back with the owner, because they're the ones that have the most to benefit from these projects, because they're hiring all of the rest of us. And then most of the documents in the program are updated on a 10-year cycle. There's some documents that are more frequent than that, but for the most part, it is a 10-year cycle. And just a little bit about that drafting process. The AIA, we have our documents committee, but then we also do market research and pull in a lot of other industry stakeholders and outside liaisons and subject matter experts, and go through a pretty lengthy process, especially if it's a new document and something that we're trying to keep up with the industry and get something out there. We really do a lot of homework and a lot of investigation and try to make sure that we are getting it right the first time there, because we don't have usually until another 10 years to kind of go back in and hit the ball again and straighten it out. So right now, I'm going to go over some of the recent things that came out. In 2017 was the last year we updated the B101 and that family of documents, and then we've had a few things come out since then that I'm going to talk about as well. So really this diagram is showing you what we're talking about when we talk about the AIA main kind of family of documents that I think most people are familiar with, and that's the A201 family, which includes the B101 owner architect agreement, and then the C401, which if you're a consultant that you maybe are using if you're working with an architect. And then we have some consultants that are working directly with the owner, and they're using a C103. And then we've got the contractor to the far right hand side of the screen, but I'm not going to really talk about that as much tonight. I think another thing we've layered in here, if you're doing a lot of sustainable projects, you may be familiar with the E204, which is it's an overlay document that gets attached to all these documents, and it really outlines the sustainability services on a project. And then we have a newer document that just came out in 2020, which is the C204, which early on the AIA being architects, we assumed that sustainability consulting was going to come from the architect, and the architect would provide those services. But we've realized that that isn't always the case. There are a lot of outside consultants that are not architects. So we have a new owner consultant agreement, the C204, which allows for those services to come directly with a sustainability consultant to the owner. And I'm going to talk about a couple of different scenarios tonight about how you could contract then for energy modeling services using these documents. So the first one I think would be if you are an architect and you're working with the owner and you're going to use the B101. So under the B101, there are a few basic services that are always considered to be under the architect, which structural engineering, MP&E. And outside of that, everything is considered to be either a supplemental or additional services. And so that if you're familiar with the B101, there's this lengthy chart in Article 4, which outlines a myriad of services that the architect can provide that are known at the time of the contract, but that will be for a separate fee, typically outside of their basic fee. And in this chart, I've just highlighted a few of the areas where you could come in and edit this document and put in the sustainability services and or energy modeling services. And that could either be under your full, if you're providing a wider range of sustainability services on the project, or if you're a specialty consultant, or if you just want to even list that under supplemental services, if you're the architect who's actually going to be providing those energy modeling services. And then likewise, if you are a consultant and you're working for the architect,
take care, Kevin,
you will typically be providing those services under a C401 if you're using the AIA suite of documents. And so I've just put a screenshot here of where you would be inserting those services. And typically you could type it in here to the contract, but typically I think the services are probably complex enough that you would be attaching an exhibit to a C401 and outlining the services that you would be providing. Now, I will qualify here the note there in red. The AIA does not currently have a scope document or a written out description for energy modeling services. And that may be something that the discussion has started, and that may be something we see in the future, but it is not something that the AIA offers right now in terms of But I know a lot of firms out there who do this on a regular basis have developed scoping documents, and that may be something even that could be shared with your local COTE committee. That you guys can pull some things together and share those as to what other firms are doing. And so likewise, if this energy modeling consultant, if you're providing services directly to the owner, you could use the C103 document. And it's very similar to the C401 in that you have a kind of a fill in the blank where you just describe what those services are going to be. Again, I think it would probably be, most cases you'd be attaching some sort of a scoping document or a proposal or something as an outline of what those scope of services would be. And then if you are providing kind of more of that widespread, you're serving as a greater sustainability consultant on the project, you might use the C204 attached to the owner consultant agreement, the C103. And in that, when we developed this back in 2020, we did anticipate that energy modeling services were going to be an option. So we've got a line in their supplemental services chart that directly relates to energy modeling, and you put in here who's responsible for it, if it's the consultant, the owner, or not provided. And as with other AAIA documents, you can change this and edit this to go in and add more text or additional language there if that description is further needed. So lastly, before I move on to other things, or we move on the discussion to things more exciting than contracts, I wanted to make sure that I took just a minute to talk to you guys about D503, which is the AIA's contract documents guide for sustainable projects. The documents committee puts out several guides, which are actually free resources to architects and really anybody who wants to look them up on the AIA contracts website. And so the D503 was actually around before 2020, but we updated it in 2020 to include the C204 and to really talk about the E204 and other things on sustainability related to the industry. So I just wanted to point this guide out and let everybody know that it's available. The other guides for the owner architect agreements and other agreements that are out there, I think there's a guide now that's going to be coming out soon for international projects. There's a guide on the sustainability, there's guides for the owner architect agreements. And really these guides are out there for people to help them understand the contracts better and to understand things the topics that surround those contracts. So just as an example of one of the chapters in this guide is really providing an overview of jurisdictional requirements and things that you might see in the industry. And that's where we were able to go in and introduce the ASHRAE standard 209 and start to talk about that so that really get that out there for other architects to understand how these guides or how these standards and these jurisdictional requirements can tie into the sustainable goals for a project and how you can use those whether you're doing LEED or Green Globes or whatever type of certification system you're looking at, how you can use this information to help further along the project and how to define it in the contracts phase of the project. And lastly, I'm just throwing out some resources here. The AIA contracts website on the AIA.org is really great. And then here's some emails and telephone numbers for tech support with the ACD5 system of contracts and just about the content. They've always got attorneys on call to answer email questions and telephone questions. And if you have any resources, feel free to reach out to me or others on the committee. We're good resources too, but the AIA has a good system in place to answer questions about the contracts. So I encourage everybody to use the resources that are out there. And that is all I've got at this point. And I'm going to stop sharing. And I can answer questions if there are any, or we can move on and answer questions at the end if that helps.
I think, Heather, are we going to go ahead and
yeah, Tara, I don't see any questions in the chat box. So
perfect.
Just a reminder to everyone, please, if you do have any questions, you can add them to the chat box. We're going to have a Q&A. We've left a lot of time for that at the end of this. So looking forward to a lively discussion.
Well, if Tara's crashing, then I'm really crashing. I'm from San Antonio, Texas, and I'm a mechanical engineer, so I really don't fit in with you all. But thank you for having me tonight. My name is Heather Holdridge. I'm the Director of Design Performance with Lake Plato Architects in San Antonio, Texas. We are a 145-person firm based in Texas with offices in San Antonio and Austin. And move on to the next slide. Sorry, my screen froze there for a second. But we are also working across the country in many different climate zones. And we are also working across a diverse range of project types, including single-family residential, higher education, urban infill development, and master planning. Our approach for each project is consistent, though. We believe that architecture should be rooted in its particular place, responding in a meaningful way to the natural or built environment. And we aim to create buildings that are environmentally responsible and authentic, artful, and crafted. So when I was invited to join this panel tonight, we were talking a lot about contracts. And it is true that in the early days of the 2030 Challenge and the AIA 2030 commitment, our firm was seeing many firms who were contractually obligating MEP consultants or energy models to our energy modelers to meet the current targets of the 2030 programs. But we made a deliberate decision not to do this. Rather, we invested some effort in developing some in-house tools to make our expectations for building performance and analysis clear so that all members of our extended project teams are working towards common goals. And one of the first things that we noticed is that proposals and scopes coming from those engineers and energy modeling consultants varied wildly. So we put together a brief template that outlines some of the basic services that we would like to see included in these scopes. Those services include energy analysis, and we borrow some language from ASHRAE 209 to clarify what type of modeling we'd like to see. And our firm has some in-house energy analysis capabilities, so we always like to have a conversation early with these consultants to establish who will be modeling what. Generally, we find that it's better for Lake Plato to lead the analysis in the early design phases when we're largely studying architectural decisions and impacts such as massing, orientation, and envelope assemblies. And it's better for the consultants to take over when systems decisions are being made because the engineering consultant is going to have much better familiarity with those specifics. We also want to include a basic comparison of various mechanical systems options, examining performance, durability, and cost, et cetera. And we also want to have some assistance coordinating the owner's project requirements and basis of design. We found that having this be a collective conversation between the design team and the owner has made those documents much more rich and useful to reference throughout the design process. This is another tool that we put together. It's an energy modeling form. This form is shared between Lake Plato and the MEP consultant to ensure that the energy model inputs match what was designed. So just a common document that we're using to establish expectations and common design values. And we have this version posted on our intranet site that explains each field so that we can all understand the inputs that are used to model energy performance. And then the last tool that I wanted to share with you all is this common set of interview questions that we're using throughout the firm. And first, I just want to acknowledge that we're not always or even often interviewing multiple consultants as engineers on our projects. But when we are, we found that this is a really great way for us to assess the different values that different engineers and different expertise that engineers are bringing to our projects. And then even when we are not interviewing multiple consultants, we've still found that this is just a really great exercise to go through when we're onboarding this consultant onto our team. Again, just as a way to establish some common values and a common approach to how we're looking at the project. So I'm not going to read every single one of these questions to you on the screen because I know that you can read them yourselves, but generally we want to establish what experience they have with the specific project type that we're pursuing and what they feel like a good energy benchmark and target would be to set for that type of project. And then we want to hear about their process and how they best like to work and collaborate. So describing some examples of things that have worked well for them in past projects and what actions they would like to see. And then getting into the specifics of performance analysis, describing their energy modeling process, describing how they've interacted with commissioning consultants and the value that they've seen from that, And then looking at other types of analysis as well, such as life cycle assessment. So I'd be happy to share any of those examples. I don't think I've seen any questions come through, so I will go ahead and stop sharing my screen and turn it over to Kit. Thank you.
All right, thank you, Heather. So if it looks good, please speak up. If you don't see my screen, it's really great to see some familiar faces and names here. So I'm Kit Ellsworth, coming from Kieran Timberlake, which is more local than the previous two presenters here in Philadelphia. Before I start, I wanted to also take a moment to introduce one of my colleagues and principals at Kieran Timberlake, Ryan Welch. Ryan Welch is going to participate in the presentation, and through 10+ years at COTE has been pioneering some processes and workflows with our energy modeling consultants. So he's got a wealth of knowledge, and although we may be pretty punchy and terse in some of our slides, we've got a lot of background content that we're really looking forward to having a pretty good discussion with after the presentation. So before we dive in, just for those who are not familiar with Kieran Timberlake, we're a medium-sized research integrated architecture office here in Philadelphia. We've got a heavy focus in environmental design and have a lot of projects, both domestic and abroad. But for the sake of today's presentation, we will highlight that we're also 2030 signatories since 2017 and have committed to doing energy models on all of our projects. So we have experience working very closely with energy modelers who are both either consultants or engineers in our projects. And we found over the years like numerous ways to leverage energy modelers to advance design and answer kind of key questions, not just around either PEUI or other metrics needed for 2030 reporting. And we understand that modeling is a process that we should not be doing alone. So this presentation here, we're going to focus on kind of ways that COTE has explored improving the process and the ways that we've worked with energy modeling consultants, and through that can kind of intuit ways that this can be built and integrated into energy modeling contracts. So just to start, here is a massive list of ways that energy modelers can be used, answering the question, why do we model? So we have kind of these broader categories of whole building benchmarking, performance-based modeling. These are all ways that we've typically used energy modelings and find out what the PEUI is, such as for 2030 purposes. But it's really a waste of modeling to think that we're simply just using this somewhat complicated algorithm of various thermodynamic equations just to be answering a single value that's representative of our whole design of a complex mechanism that is a building. So each one of these questions, whenever we ask them on a project, require different processes and different levels of details. So for example, that whole building compliance benchmarking may rely on ASHRAE default values, populating the model with all these default values. And we're simply just benchmarking against that baseline and showing either maybe percent reduction in energy costs for LEED or percent energy use reduction for code. Whereas the next category down, performance-based modeling, are ones that we need to be super specific on how much energy we're using because we are sizing either a battery bank or a PV array based on that prediction of annual energy use. So those are types of questions that really guide system design and drive design forward completely. So when we ask these questions like that, it's really important to scrutinize our models and our inputs and work with our consultants to help understand, where are those huge sources of uncertainty with our inputs. So here's a Trivial Pursuit-esque diagram of kind of these really broad 8 categories of energy model inputs. Anyone who's had experience with energy modeling knows that, there's many, many other layers of inputs below these just high-level categories. So the wedges to the right here are pulled out because those are ones that we feel that the architects have influence over. For example, building geometry, siting, these are just inherently through the design process, we're constantly shaping these inputs that are drastically and probably most significantly driving energy use. However, some of the other ones are here some kind of those sub layers of some of these inputs here. So as I mentioned, siting, massing, and the envelope values, through our detailing and envelope design, we are influencing our values and U values. However, for those other wedges, those fall more appropriately into the domain of an MEP or engineer. So it's really important to recognize that, And there's also this third category here of what we maybe call like intrinsic variables, ones that we have very little control over in our design process. Use schedules, occupant densities, set points. These are things that can be changing through design or through operations. And there's also this whole other category of kind of like unmodeled model form uncertainty that are just based on the way that your energy modeling software tries to predict energy use. They're all very different in very small different ways, and without knowing that, we can lose out on some of the predictive capabilities of our model. So we do recognize that getting involved with some of these inputs has a lot of benefits. We understand that our position as architects can enhance the model fidelity, but also act as kind of this key mediator between different project team members to help improve the accuracy of the model. So for example, we work closely with envelope details. So understanding what that R value might be, or on the other side, for those occupancy schedules, let's say, we can act as an intermediary with the client to understand what's a typical use pattern for your building. So we'll go into these a little bit deeper, but we also recognize this may be a little atypical, for architects to participate in this process, but there's huge benefits to this. So here are just 4 statements that summarize kind of our position on why we care so much about this energy modeling process. So first, we make better decisions when we conduct targeted studies using energy models. And this is really speaking to using energy models more than just for code compliance, understanding its capabilities for thermal comfort, sizing, operational carbon, and that we want to support and engage energy modelers and identify ways that we can improve their process, make it easier, and understand how we can use models and leverage their expertise to answer kind of key design questions. And then understanding the assumptions. This is going to be really important, as I was speaking to in the last slide, because all these inputs dictate performance, and we need to be able to also translate those to clients to help our clients understand why we're reporting a certain performance level for our building and what's driving that. And then that last one is finding opportunities to really author and QA those. So finding opportunities to help kind of improve the fidelity and representation of our model of the actual building. So we'll show some case studies that highlight these. And first, we're just going to go into kind of how we've considered the process itself. So asking, what does a traditional consultant-related workflow look like? So anyone who's had experience with energy modeling consultants may have had experience with this type of handoff or this type of process. So this is most of the kind of the simplest way is either architects will hand over, a drawing set, specs, maybe a spreadsheet, and then the energy modeling consultant will take that and translate that into the proprietary energy modeling software, which takes a significant amount of time. And it usually translates to 1 model per phase, just with the whole kind of time it takes to go to do all that translation. And the reports are, typically maybe energy use, energy cost. It may not be giving any actual feedback to improve and advance design. So how can we improve upon that process? This may be more common. Architects selecting kind of 1 iteration from a series of different iterations and during the design phase, handing that off to a modeler. Either that consultant then translates that or uses a different program to get that model from maybe a Revit file into an energy modeling file, or rebuilding it on their end. But then the energy modeler primarily authors that model and reports the results back, hopefully maybe mid-phase in this example, helps the architect then generate some more designs based on those findings, and then repeat the process with kind of an updated or improved model. So for obvious reasons, this improves upon the previous slide in terms of the 1 model per phase. It's a bit faster, it's a bit more iterative, but what we see as aspirational is this concept of a shared model. So this is kind of our current and proposed process. It's this kind of cloud hosted energy model where either project party can kind of conduct these isolated studies based on the model, either take kind of focusing on key areas. For example, if you take those kind of purple wedges as maybe envelope properties, the architect can then iterate and study window wall ratio, shading, whereas simultaneously the consultant can be looking at maybe system design and peak load analysis, so that there's this constant evolution of design that's all being informed by performance analysis. So we'll confess that we haven't fully achieved this workflow. It's definitely aspirational, but we see a lot of other advances in the field that are working towards this kind of common approach of a shared energy model that can be leveraged for many different types of performance analysis. So lastly, when does this actually all start? And I think it's important to realize that it starts early as the RFQ or RFP. It's important to have the right people on your team and really set yourself up for success. So that's identifying what the goals are, both from the client side and also from the kind of project team design side. It's setting up interview materials that do identify kind of energy or carbon as a key goal here, and understand how, what tools, what processes we're going to use to study and advance that. And then another step, once you have, the project, it's going, you have your team members, is to perform an energy modeling kickoff. And this has been extremely beneficial where once we're up and running with the project, we assemble as a group and we review these items here that are bulleted. We talk about the timeline, the goals for the model, what iterations we're doing, how many iterations we're doing, what modeling software is being used, what workflows the consultant is open to, what they've done in the past, what's been successful, where we can find opportunities to improve upon that. And also talk about reporting metrics. That's also, we'll have a slide on that, but talking about what metrics we need to answer those key questions, either for 2030 or for design. And then that last kind of column there is more about the modeling cycles, which is speaking to those previous slides. So we'll show some examples of where we've explored some of these methods and processes and engaged in supporting modeling efforts, co-authoring energy models, or asked for specific iterations, in terms of driving us towards a net zero or 2030 compliance option. So Ryan, I'll invite you to talk about this one.
Sure, happy to. So in discussing some of those traditional modeling workflow sticking points with our engineers, we've had a number of conversations over the years, and one of the points of friction that we found to be really common is simply about building geometry and reconciling building geometry, thermal zones, and their associated internal loads between an ever-evolving architectural model and an energy model. So starting, I guess, with our NYU Mercer Street project, which had, I think, around 500 thermal zones, so a very large project, but then continuing over a number of projects over the years, we've developed a workflow wherein we can actually maintain a really nice clean set of energy model plans within our architectural models, and at any moment spit out to our engineers a really nice clean open studio model for them to iterate with. But I think it's also worth noting that in the past 5 years since we first pioneered this workflow, there's also been an emergence of a lot of tools that can also purport to handle the same process. So we're constantly reevaluating some of the new and emerging tools like ladybug tools, honeybee, pollination that carry out essentially the same purpose. And we're always looking to find on each project what is the most efficient workflow with our consultants, where we can both ensure model fidelity and really have a transparent set of model inputs that we share. And some lower hanging fruit, Kit, if you want to go to the next slide.
All right, so other opportunities where we find kind of under the category of co-authoring is ways to go just beyond either assuming that each energy modeling surface is kind of a uniformly applied U value or R value. So I think everyone in the call probably understands the concept of thermal bridging, but whether that gets applied to energy modeling is a different question. So many code values may be expressed as either prescriptive R values or U values. So we've taken opportunities to use other analysis tools like Therm to quantify the impacts of mullions, thermal bridges through studs, slab edges, and find ways to improve the accuracy of those U values that we use in our kind of like basis of design or proposed case in our energy model to be more representative of the conditions that are being designed and built. So these are going a little bit beyond just maybe taking like a series R value that kind of just cuts through the layer of insulation and adds a little bit more of a reality or kind of realistic representation of those envelope values. And in terms of sharing those values, we found a lot of success in having, I guess, what we'd call like an energy model input matrix. And this is going to be as simple as just like a spreadsheet that we share with our energy modeling consultants and any of the project team members, where we can document our inputs. And this becomes really key because on some projects, we may have multiple baselines. We may have a baseline for lead, we may have one for code, and we may have some iterations we want to explore beyond kind of the basis of design. So having this kind of all laid out in this very messy fashion, because it's also helpful to kind of jot notes down, have this kind of transparency and communication with our consultants and engineers in terms of where these values are coming from, either, you know, what's the reference, how do we calculate these? So we found this extremely useful. This could obviously be hosted on a SharePoint to allow kind of simultaneous feedback and input as well. So in the topic of some design variables being outside of our domain and our control, this is a slide that we've used on a project to communicate to the client and understand and kind of look for feedback on how they anticipate using the building. So you're seeing kind of 3 usage profiles here that demonstrate daily energy use and a size of a PV array that supports that. So this is a project, this is a residential project that was going to be off-grid. Off-grid projects with solar need to be designed around kind of the worst case condition, typically like, you know, the coldest time of year where you're drawing the most power, need the infrastructure to support operations. And that's all going to be tied back onto, you know, energy use and heating. So we kind of outlaid these 3 different paradigms of energy use from low, medium, high to really get feedback from the owners, which then we use for modeling purposes. And this was really helpful because I think instead of you know, trying to outline schedules or other ways that we typically energy model, we just simply put it into duration of appliances and tied that back to actual system design and infrastructure, which I think as an educational and awareness tool really worked as well, because clients get that understand the direct relationship between you know, behavior, appliance use and system design. And you know, for any kind of net zero off-grid house, that becomes a critical piece, is that user awareness and understanding that link between appliance use and system design. So another thing we've started to do is asking our consultants to identify how to get to 2030 or to get to zero carbon to zero energy. And in this imperative, we ask them to kind of forget any project constraints or budgets and find kind of the architectural and mechanical solutions that deliver us to that goal. So in this example, this is for a university lab building. We have 4 options laid out here where like the alt systems 1 and alt systems 2 are kind of adding on kind of more aggressive mechanical and architectural interventions and trying to drive down energy use as far as possible. So that alt system 2 is representing kind of like everything we can throw at it. And you can see through that the lowest we could possibly get is around 63 kBtus per square foot. So from that, we know just through architecture and mechanical systems alone, we can't quite get there. So we need to layer on some type of renewable energy or offsets. So for this project, we then identified, you know, how many energy credits. Well, on site was, the site was pretty compact, and the roof area being pretty small relative to the whole gross square footage. So on site was a sliver here. So we had to look to offsite credits. So this helped then quantify how many renewable energy credits they would need to offset that rest of the energy to get us to 2030. And then, you know, translate that to cost. Annual cost is a way to kind of layer on a kind of fiscal perspective as well. So this has been really helpful, you know, on all projects, so that we can identify kind of extreme measures that may not be so extreme once we actually bring those to light. You know, there may be inherent opportunities or synergies between some of these, you know, passive opportunities and other things like radiant heating and cooling, you know, freeing up some maybe floor or ceiling height area that may unlock some other goals or values that the client has that we didn't know existed before. And lastly, so I spoke a little bit about energy model reports being kind of really important. So we find that energy model reports are not just great for compiling a lot of the results data, but also then disclosing a lot of the input data as well. So these kind of 4 general categories are things that we request from energy modeling consultants, modeling the model, like a screenshot of the actual model with context. Sounds something extremely mundane, but this has actually been hugely useful. Like Ryan and I, a number of times, just having a screenshot of what's in the model, something you probably never see before, or maybe never see at all, will show you, is this the right building? You know, is it oriented correctly? Is this the right version of the building that we're curious to study? And like, are all the buildings around it represented correctly? And we've had plenty of opportunities where it's not been the case. The tabular input data, just great to kind of disclose this both for the baseline and the proposed condition, and this includes envelope values, lighting power densities, equipment power densities, making sure those are all representative of what you'd expect for your building as well. It's a really great feature of this. Diagrammatic schedules for set points and occupancy schedules, very, very helpful. 90% of us architects here are probably visual learners, so getting these out of kind of a fractional schedule is very, very helpful for us to then see this, easily critique it, and then possibly share this with the client as well and make sure it kind of checks, makes sense to them as well. And then lastly, the results. Showing this both graphically and in tabular data is really great to be able to then, if you ever want to critique, run some other kind of like back of the envelope calculations on reductions to primarily heating energy or cooling energy, getting those numbers is really helpful instead of just in a kind of stacked bar graph, but the stacked bar graphs are always useful for seeing that energy use breakdown. So to bring it home, key takeaways, as I said, start early with the RFP and set the team up for success with people who are oriented around the same goal, the same approach, are open to exploring new energy modeling processes. And having those kickoff meetings is also extremely important, where per phase, you can look at goals, iterations, timeline, schedule, everything else. And then through that, finding ways that architects can be real allies to the energy modeling process in terms of leveraging the architect's relationship with the client and other project team members to help improve the accuracy and the fidelity of the model itself. And then that iteration, the path to 2030 or maybe path to net zero option is a real helpful educational tool. So by asking that up front, at least you know that'll be delivered. This is probably most useful, maybe early design phases, like maybe the first modeling cycle you go through, and understanding what it takes to take the building to the next level. And then lastly, those energy model reports, really good QA, quality assurance measure, understand everything looks good. The energy model actually is your building and it's being represented correctly, can go a long way. And having that as also an archivable document is always useful to go back if, when you're reporting 2030 data, you got to dig up your energy model report and find out what that EUI was. So having that in, PDF or whatever is extremely useful. So that's it for our slides. I hand it back off to Josh, maybe, or Jonky.
I got it.
All right.
Pass it this way. We did get a question in the chat box, which I think Ryan might have hit on a little bit in his presentation, but I'll just add it here if any of the other presenters want to chime in. So Camilo is asking, for the ideal process, what software platforms are you using or considering to use? We get this question a lot and it's quite loaded, so I'll let you guys try to take that.
Yeah, I mean, so obviously it's an aspirational workflow. We're not at the ideal. None of what we showed, I think, purported to even come close to that. But I think I can describe some of the functional attributes of what we might look for. I think we have to acknowledge that architects are operating in the design software that they're comfortable with, as are engineers. And whatever that solution is, I think it has to work very seamlessly with our native modeling platforms, acknowledging their shortcomings, or perhaps more specifically that their shortcomings in the context of being applied to a task that they weren't necessarily built for. So I think it's probably something that is cloud hosted, so that even somebody who just has a web browser can get in there and test out some, changes in numerical inputs. But then I think there's also probably some interfaces between, say, Revit or IES or other tools that people use.
Okay. Didn't see any other questions that came in, but I hope that answered your question, Camilo. I'm going to start sharing my screen again. Oops. Share here, not through there. So Molly's asking while I pull up my screen. I'm curious to hear from both Kit and Heather how documentation of your energy modeling inputs make it into the project documents. So like, how does it get into the basis of design or the OPR? And yeah.
I can go first on that. I mean, it's absolutely included in the basis of design. And I wouldn't even say that it's a sustainability basis of design. It's just the basis of design. I mean, we're definitely including envelope thermal values, looking at mechanical system efficiencies, and we are updating that BOD throughout the design and construction process to make sure that we all have a common platform we're working on when we're trying to reference inputs.
Kit, Ryan, was there anything you would add to that, or?
I would certainly second that, and I could just give an example. Whenever we're doing projects that have an aspect of the building envelope that's delegated design, such as curtain walls, we'll take the modeling that we've done, such as Kit showed us in Therm, or work that's executed by a separate envelope consultant that proves what is achievable in terms of overall system U values and solar heat gain coefficients, and we'll write that into a performance spec. So we may have a couple different manufacturers in mind, but we know that those targets are achievable, and we'll hold the contractor to that.
Awesome. So if there's no other questions, we have a couple of oh, wait, there's questions coming in. I will stop not sharing. So Brian Smiley's asking, having a view of the energy model geometry is great. I always ask my modeler, where are my sunshades? And then we have discussion on how we factor them into design. What impact they have on the energy performance, and are they really making a difference? So how would you?
That's a good question, a good observation. I wouldn't say shades are kind of like too fine, at least from what we've found. There are certainly elements that may be simplified in the energy modeling process. Other ways, I think, to get around maybe modeling, an example kind of directly applicable to the shades is, I think Ryan had experience with that same project with NYU, is trying to understand kind of the solar heat gain reduction that shades could provide. And using that as kind of a key modeling input then. I don't know, Ryan, if you want to elaborate on that process, I think you could probably speak to it more.
Yeah, I think this is one of those great examples where the level of the fidelity in terms of geometry in the energy model just had to be much coarser than what the architecture would suggest. As a building with a curtain wall system, with a lot of kind of tilted panels that were really critical to solar shading. So we worked very closely with our energy modeling consultants at Atelier 10 to develop a workflow wherein we could do more of the detailed incident solar radiation modeling and actually produce a series of essentially coefficient schedules for every hour of the year for each thermal zone. And then they were able to apply that as modifiers to solar heat gain coefficient of the glazing properties, and actually model much simpler geometry. So it's one of those things that really difficult to capture in a model if you don't have that very tight kind of problem solving collaboration with your consultant.
Another example is, I think, when we've accounted for either like on-site trees, similar methodology where we have created kind of a solar fraction schedule of tree shading that maybe accounts for seasonality, but also just diurnal solar trespass across the sky. So that's kind of another example of where energy modelers may be resistant to include really detailed context geometry like trees, or not at all. But we could use just simple solar analysis to be able to create a schedule that accounts for tree shading that they could apply to glass or envelope.
So not being one of the presenters, but I thought I'd just chime in here. I recently also learned, tying back to one of the questions on tools, that some tools actually aren't capable of factoring in that level of detail when it comes to shading too. So like that's another important thing to keep in mind, that the tool might not consider it, and so then the modeler might not spend the time to actually model it, in which case the resolution of your model from the baseline to the end won't be taking that into consideration. So it's all right. So I'm going to share my screen here now. And we had some like questions that we had kind of had as, I guess, kind of like around the topic of how do you solicit an energy modeling proposal, and how do you evaluate the results? I know Kit kind of touched on some of that with the case studies, but maybe we can just kind of talk about that. Like, how do you know what you need modeling for as a starting point? Like, I think all of the presenters can probably chime in a little bit on this to say, where do you start?
I think one issue that we're constantly trying to avoid is just doing energy modeling for the sake of doing energy modeling. As we all know, running an energy model in the early design phases and coming up with an EUI and assessing whether or not that meets the 2030 challenge target can be not very meaningful. So I always encourage project teams to come up with some very specific questions for
Sorry about that.
either our design performance.
We have our holiday
team.
party
Sorry.
tomorrow, and we're having a.
Somebody mute Brian, please. Thank you.
Yeah, got it. Sorry.
Yeah, thank you. I always encourage our project teams to come up with some really specific performance questions, either for our internal modeling team or for their external consultants, because we've just found that's the most rich way for us to have a dialogue about whether or not we're meeting our performance targets.
And I'll chime in there. I think this is really important from the contract side of it, which is not always the most exciting part of this, but in terms of defining what your owner's goals are, I think understanding and getting that in there, the AAIA documents are asking you to define what the owner's sustainable objectives are. And I know just by the complexity that you've heard tonight from Kit and Ryan and Heather in terms of these models, getting that information out there early on in your contracts is important, just so that you have clear expectations with the owner on what you are providing. And then if they come back later and say, well, I want to add and layer this X, Y, and Z on top of that, then you have contractually that basis for coming back and saying, look, that's not what we agreed to early on, and I'm entitled to some additional scope and services for that. So I think a lot of people tend to just gloss over that in the contracts, but I think that's pretty important in terms of defining up front and setting those clear expectations with the owners on what you are going to be providing.
I think in terms of client expectations too, models can give in terms of outlining the full range of, not the full range, but a huge range of different outcomes as well. I think there's numerous times that maybe people in this call can relate that you've maybe designed a building that had an energy model report attached that showed a single PEY value, and the first year, the second year, the building doesn't achieve that EY value. And that's, I think, by nature of the way that energy models and rating systems are set up to just obsess or focus on a single EY value. And I think that can be corrected, but energy modelers can help us, or energy models and modelers can help us then kind of communicate the full range of outcomes and at least understand where the greatest sources of uncertainty or sensitivity are with models.
Awesome. So we did have another question come in from Brian. It's for Heather, Kit, or Ryan. So how do you resolve early decisions such as the relationship between floor to floor height and ceiling height and associated pressure loss and fan energy when you have pushed the floor to floor too low and the ceiling height too high, assuming a drop ceiling? Perhaps there's a continuum from straight runs to Swiss watch. What are the factors used to measure this system complexity?
I feel like I've been jumping on these first, Kit and Ryan. Do you guys want to start, or I can go first?
No, please. Yeah.
Go
I'll hand it
for
over
it.
to you.
Yeah,
Resident mechanical engineer.
Yeah. Well, I was just going to offer that I actually feel like this is in one of my first slides in my presentation, I was talking about some of that template for services that we always want to be included in a scope for this type of work. And energy analysis was in there, but a basic comparison of mechanical systems is also in there. And I do feel like that type of question is actually better addressed through the mechanical systems comparison than it is through energy analysis, at least in the earliest of design phases. And I say that because when we're evaluating all of the different criteria that we're looking at, that includes, energy performance, it includes durability, it includes both upfront and operating costs, et cetera, et cetera. But I think that distribution is a part of that as well. So we're ranking each one of those criteria so that we can make the best decision for a mechanical system on all those criteria, and hoping that there is some energy analysis that's also informing the results of that mechanical systems comparison. So it's kind of both of those tools working concurrently, if that makes sense.
Yeah, I would say in our experience, we haven't addressed that particular question that hasn't come up, but it's sort of in a flavor of questions that sort of, in order to answer it accurately, would require typically a level of development beyond where we are at this early stage. And in that respect, what we've found is that it's really helpful to rely on our consultants' intuition and past experience. And if this is a question of maybe evaluating different distribution approaches or mechanical systems, we might ask them to produce a matrix of different options and consider them across various evaluative criteria. First cost, overall energy use, long-term maintenance, et cetera, and one of those may be space constraints, whether it's plenum space, the amount of floor plan that you have to give over to vertical distribution, or the amount you need for your plant or heat rejection on the roof. Those are things that are really difficult to quantify accurately, but often if you just ask an engineer for sort of gut, is this better or worse, they can provide that for you.
Yeah, I think as Ryan said, we may not have encountered this issue, but a similar kind of instance where drop ceiling to ceiling height has affected energy use and has happened unfortunately late in design is where either like drop ceiling is either taken out of a design, and then it increases the volume of the space and impacts ventilation and drives a lot of heating energy, specifically with flat buildings that can have a huge swing in energy. So I think as Ryan was saying, maybe knowing kind of those sensitivities around what your program is, the climate zone you're in, to watch out for and know that those are huge triggers for energy use. So if you do have a lab building in a cold climate, try not to increase ventilation rates through design, or at least know the impact, if that conversation ever comes up. So yeah, it's one way to leverage the expertise and knowledge of our engineers and modelers.
I think a lot of what our firms were sharing were not necessarily tools that with a unusual degree of precision, like determine what the energy use with these different decisions is going to be. It's more about establishing a common understanding for the energy and performance goals that we're trying to achieve, so that we're all bringing up impacts and influences on energy use as we go through the process. So I think the kind of question that you've just asked is one that we wouldn't be able to answer with a great degree of precision at the beginning of the design phase, but by providing these resources, providing these different tools and templates, we've now at least established a common understanding that these are the values the aspirations that we're trying to meet. And hopefully it encourages our consultants to bring up those types of impacts that we may not be totally cognizant of.
I think another useful process that we've found kind of is a way that we can bridge either the complexity of a whole building energy model to ways that architects can kind of harness the more accessible tools to drive design forward, is asking for kind of like quantifiable benchmarks or thresholds that just relate to maybe solar gain or envelope gain. So if we're asking from the engineers, give us a goal for solar insulation or window-wall ratio on this facade, it's something we can take in isolation and study that advanced design through that while still respecting kind of what the limits are for mechanical systems or energy goals. That's been really helpful and something that kind of can be maybe, I know it's super specific, but asked for early on is like kind of more palatable, architecturally palatable metrics that we have the capabilities of using Ladybug tools for and studying that in isolation.
That was awesome. Last call, if anyone has any questions and is not able to type into the chat box, you can totally unmute yourself and go ahead and ask questions. I'll give it
Can I ask a question in the
Yeah.
meantime for Tara? So I guess I'm curious about the cycle of updates for contracts, and I'm wondering, I'm extremely naive in this category. So have there been any instances that either such as like a climate crisis or any urgent matter has accelerated that cycle so that we can, like, for more sustainability oriented contracts, that are we going to wait another 10 years for it to get updated? I know we're talking, yeah, it's not setting goals, it's more setting frameworks, but is there any example of that?
Yes, definitely. So I will say some of the exceptions that to that 10-year cycle are the things that are moving more rapidly. So BIM definitely has been something that has been updated more recently than the 10-year cycle, and sustainability. If you looked at the history, which I didn't show today, of the sustainability in the B101 and how they went from kind of this just mentioning of the architect will incorporate, consider sustainable design, and then it went from there to these SP project exhibits. And then quickly, I think there was an understanding that the SP exhibits weren't working. And so then they went to the E204, and all of that happened much more rapidly than the normal 10-year cycle. So I do think that a couple of things. One, the AIA is listening. If there are things that are at the top of people's lists that we need to respond to. And actually, I think my participation in this call came from one of those. Kim Shin, who's a local engineer here at TLC in Nashville, is on the ASHRAE committee, and he reached out to me asking questions about a scoping document and how we might be able to get that into play. And I think the more that the industry groups like ASHRAE ask questions about how we get things into the documents. Now, the AAIA documents, I will say one thing we told Kim is we're not going to favor one, proprietary system over another. And I think that's one reason why we have actually gotten rid of the lead document for services and went more to the E204, which is more of a general sustainability scope of services, because I think they want to be fairly neutral in the way that they approach this. But as sustainability is a huge goal for the AIA right now, and it's a huge one of their key kind of pillars of the industry right now. I think that the more that the documents committee hears that these things are important, then those changes will happen more often. When I say the 10-year cycle, it's more getting something into, say, the B101 or those core big documents. In terms of new documents, that's probably more of a 2 to 3 year cycle. It takes us about 2 to 3 years to get to there's 35 members of the committee. They divide us into 5 or 6 task groups, and we usually have an assignment of 2 or 3 documents that we're working on, and that process takes about 2 to 3 years to go through that full review process on a document. So
Okay, thanks.
Did that answer?
Yeah.
So
That's awesome. So I'm going to take this opportunity to continue on with the presentation if there's no other questions. So I wanted, it's nice. Usually I'm like doing this in 1 minute or after the session's ended, but I wanted to talk a little bit about what's coming in 2022 for the 2030 working group here in Philadelphia. So we're going to change it up. We might not be doing monthly sessions, but I hope that doesn't disappoint anyone, because we're planning to introduce workshops. And that was one of the things that was asked for greatly, was like, it's great to hear about these topics, but we want to, like, people want to use the skill sets or implement some of these skill sets. So we're going to have 3 main topics next year, where we're going to have one, the first a series of sessions is going to be focused on goal setting. The next is going to be focused on carbon, and then energy. So we'll do a presentation type session as a kickoff, followed by 1 or 2 workshops on each topic. And we're hoping to actually implement an application process. So I have a survey that I'd love everyone to take and give us some feedback on what you would think, like if there was an application process, or if there was a fee, what kind of impact that might have on your attendance. I think I added it to the chat earlier, but I can add it in there again. So if you have a few minutes and you can answer a couple of quick yes, no questions, that would be really helpful. And it's the link to everyone. We also have a couple of announcements at the end. So AIA National is offering office hours for the DDX. So in January next year, January, February, and March, there's going to be questions before the application period. So if you want to, go ahead and get the link for you. Register for any of those open office hours. Please go ahead and do that. And just want to say happy holidays, everyone. This is our last session. It was a marathon year of all virtual sessions. And yeah, we're really happy. We're ending in a good place, and we're looking forward to next year. Our monthly meeting is going to be next week. This week on Thursday, 8 to 9, same time. There's a link. We're always looking for new members to join. So if you haven't joined our meetings, please consider joining. Awesome.
And I would just like to, as Jonathan just posted, thank our presenters. I think this was a great presentation to end the year on, to really kind of, get into, some of the how to get there. We I think focused on topics, as I mentioned at the beginning, for the first several months. And, the last couple of months, we've been focusing on how architects and engineers approach the process from their perspectives. And I think what we're hoping to do today was kind of bring that collaboration together and kind of talk about ways to set that up from the beginning. So I think the presenters did a great job of kind of spelling that out, and from how to integrate that into contracts, but then also how to work together, and how to kind of how important it is for the architect to get engaged in the modeling process, and also bring the engineer into the design process. So I think this was a great presentation towards getting to the 2030 targets. I think we all know that the traditional process only gets you so far, and we need to kind of get over that hump. So thank you again to all the presenters.
Yes, thank you, everyone. This was an amazing session. All right.
Happy New Year.